Hello and welcome to the latest in the EDIAQI webinar series, this time co-organized with the Twin Air project. Please, we're going to do some housekeeping rules to begin with now. Very important, please do turn off your camera and mute your microphone. This is to ensure that there's no disruption for the speakers. The session is being recorded, so please do be aware and don't turn on your camera and microphone if you don't want to be recorded. The presentations that are used today will be shared afterwards. And please, any questions, comments that you have at any point, we want to hear them. We want you joining in the discussion. So please do ask questions anytime in the chat. The chat is open just for that. And then captions are available. Kindly click on more, then language and speech, where you will find an option to turn on live captions. Affordable indoor air quality sensors, many of which have fallen in price by up to 90% in the past decade, are rapidly transforming buildings into continuous data environments. Classrooms, offices, and public buildings can generate millions of data points each year across CO2, particulate matter, humidity, temperature, and volatile organic compounds. This data has the potential to unlock better real-time building management, continuous improvement, and more informed public decision-making. When integrated into intelligent systems, it can optimize ventilation and filtration. And when made accessible to occupants, it can empower them to take ownership and promote behavioral change. Yet, the challenge is no longer measurement, it's interpretation. Indoor air quality is a multidimensional, context-dependent, and inherently variable. A single classroom sensor can produce more than 7,000 data points per day. Multiply that across buildings and pollutants, and the result is a complex data ecosystem that risks overwhelming users rather than guiding them. Oversimplified dashboards may conceal uncertainty and health-relevant nuance, while overly technical interfaces may paralyze action. As IAQ becomes more central to public health, renovation policy, and the zero pollution ambition, the design of dashboards becomes a governance question. In this context, the EDIAQI project is convening this webinar to address three core questions. How much complexity is necessary to preserve the scientific integrity of indoor air quality data while ensuring that it remains actionable? Should IAQ dashboards prioritize thresholds, trends, uncertainty, or health impact? And how can uncertainty be communicated clearly to non-expert users? And finally, how should dashboards design differ when intended for engineers, school managers, policymakers, or citizens? And could composite indices enable comparability without obscuring health-relevant nuance? So with that, we will be doing today the Out of Thin Air Making IAQ Data Make Sense webinar co-organized with the Twin Air project. And joining us today for this timely discussion, I'm proud and honored to introduce our outstanding panel for today's latest installment. Starting from left, we have Sotiris Papatanaseu, founder of Global Open Air Quality Standards, Marina Malero Munoz, R&D Project Manager at IES Limited, Michele Ferron, Service and UX Designer at Pier Giorgio Cipriano, Information System Project Manager, also from DataNext, and lastly, Sumit Kumar Nair, Researcher in Behavioral Science and Design and Digital Trust from also DataNext. So we've done the welcome and introduction. We'll be heading to engineering clarity, translating complex IAQ data into practice with Sotiris. Then from there, we'll head to digital twins and decision making, simplifying complexity responsibly. And then from interface to influence. I'm so sorry. I will just be turning off your microphone. Apologies there. And then we'll be heading to digital twins and decision making, simplifying complexity responsibly with Marina. Then we have, for the first time, a group presentation from DataNext, which is a little bit longer, which will look at from interface to influence, UX, nudging, and trust in IAQ visualization with Michela, Pier Giorgio, and Sumit. And then finally, we'll have a panel discussion and all of your burning questions will be answered during the interactive discussion. Now, finally, we'll have some concluding remarks. So with that, I would like to give the floor to my dear friend Sotiris to take it away with the first presentation. Please, the floor is yours.
Alex, it's such an honor, a pleasure again to be here with you and among all of the attendees that are here with us today in order to learn a little bit more about dashboards from me and the other panelists. So can we go to the next slide, please? Yeah, next slide, please. I'm the founder of GoAQS, and GoAQS is an organization that is trying to formally come to a consensus among the experts out there, whether we are talking about the academia, the industry, and so on, about how we need to protect people indoors and how we need to communicate air quality with a variety of different groups of people as well. For this reason, apart from having limits inside GoAQS for different pollutants, we also have established a score system in an effort to make this communication easier. And the Go AQSI score is a real-time tool that gives people the power to act as soon as air quality drops. It builds to provide interpretability, meaning that it turns complex data in clear why that both people and smart systems in buildings can understand and use in order to fix the problem instantly. Next slide, please. So we had to understand a little bit better what's happening with already indexes out there or score systems from proprietary organizations, but also from public environmental agencies. For the indoor space, we've never had something like that from governments. So this is the first time we are trying to make a tool in order to assist that specific need that we have identified. So as you will see here, we have a variety of colors, a variety of numbers, a variety of scales and levels that determine whether the air quality is good or bad inside or outside buildings. And also the names that they are used by all of those organizations are quite complex in order to wrap our head around. So we had to go and analyze the number breakpoints, color range, and language in order for us to see what's the best approach and what's the best, again, numbers and language in order to communicate easily, which was very important for us from the beginning, air quality with the public. You have to understand that air quality is not only for the experts, it's also for the everyday people, that they don't have the understanding of what certain numbers mean, or even what, for example, healthy for sensitive groups means, which is one of the terms it's used from some indexes out there. And by the way, if you are exposed in the unhealthy for sensitive group for a long time, you become the unhealthy sensitive group eventually over time. And that was a problem for us. We wanted to be very clear. Next slide, please. And we wanted to be clear, but we also wanted to be as inclusive as possible. So for this reason, we created something which we call the color vision deficiency matrix, where we define some colors and then we analyze them based on some simulations that exist out there about different blinding. So basically, there are people that they cannot see red color or green color or blue color. So we ran all of those combinations with the simulations, and then we asked people that we already have inside GoCase with that specific deficiency to tell us which combination of colors is more seen by their eyes and also by the simulation, but because we were able to see how they interpret the different colors. So we came up with a solution on that, and we forgot about the green color, which was like 8% of the male population unable to see. And we decided to go with the blue color in order to say that air quality is good or bad. There are other reasons why we chose blue instead of green. For example, another reason is because the sky is blue, so we can interpret in our minds better on whether air quality is good or bad inside buildings. Next slide, please. With the help now of the industry, we are taking that philosophy methodology, if you like, and we are applying it into real life. So we have examples from maps that they're using our methodology in order to display air quality across the globe. The first example with the map here is from the indoor CO2map.com website, where basically they share with the world openly what's the situation related to CO2 levels across the world, not only Europe. And now they have embedded our methodology in their product in order to make communication easier with the public. On the next image, we can see a dashboard where this specific company, AirVoice, has decided to use our methodology again in a floor map in order to say to the managers of the building or the users of the dashboard where is the problem inside the building, if it's any, and what's the historical data tell us based on, again, our colors and methodology. Next slide. And of course, there are many other companies out there that they are working to embed our methodology in their products, from simulations online that they can users can use in order to understand better how the system works, from a variety of dashboards from InBuild, from Indoor Care, from some companies in Singapore. So it's not only about Europe for us, it's about the whole globe that we want to adapt the same methodology in order to communicate our quality in the same way. Next slide, please. So here we can see a variety of companies that they have agreed eventually to adopt our methodology, and we look forward to showcasing all of those different examples, but always by having the same common language, which is very important for us. And I think it's very important for everyone, because you will see a product from products from different companies, and they will communicate air quality in different way, which creates a barrier at the end of the day, because what I understand, maybe it's not the same what someone else is going to understand. And we just like to bring this uniformity in the language that we are using. Next slide, please. And the reason we are doing that is because we want people from all ages with different backgrounds to be able to make better decisions when it comes to air quality in the indoor space for themselves, first of all, but also for their families and loved ones. So that was my presentation. It wasn't a long presentation, and I would like to thank you again. But I think the essence is one, air quality is very important, and we all have to work together in order to communicate the same thing over and over. Because if we are sharing different messages to people out there, they get confused and eventually they forget about it. Thank you.
Thank you very much for theories there. I think the key word there is inclusion and accessibility. It's really lovely to see the focus there on making sure that these instances are approachable and accessible for all and readable for all. And I very much like the point about going beyond Europe as well. Obviously, we're European focused, we're a Horizon Europe project, but we do hope that our knowledge and results that we will get from the project and the technologies and innovations will spread beyond Europe as well. Thank you very much. So now we are we'll hear from Sotiris. If you have any questions, please do ask them in the chat. They will be answered during the interactive portion, which will come towards the end, but we want to build up a big bank of questions before we get to that point. Now let's head to Marina Malero from the Twin Air project, who will be presenting today, our next presenter. Please take it away, Marina. The floor is yours.
Hello, everyone. Thank you very much, first of all, Alex, for having me. I'm very excited to be able to share the work we've been doing on Twin Air. Without further ado, I'm Marina Melero. I work in the R&D or R&I department at IES as a project manager. So today I will briefly introduce you the project Twin Air and focus on how digital twins can support a clearer and more responsible decision making, and particularly around indoor air quality, as you know. And I also show how this thinking is reflected in the tools we are developing and testing within the project. So first and quickly, before moving on to the introduction of Twin Air, I just wanted to let you know who we are at IES. So IAS is a company which focus is on enabling better building and smarter cities. For this matter, we believe that every building everywhere can be decarbonized. So our purpose is to develop this technology that make it possible. In our case, we work with digital twins and physics-based analysis. So we support the built environment, and we try to make resource efficient and reduce reliance on fossil fuels. So ultimately promoting comfort, health, and well-being while improving also access to energy for everyone. So next slide, please. Okay, so here you have a quick snapshot of Twin Air. So Twin Air at a glance, we are a Horizon Europe project. We have 22 partners across 10 different countries, and it's ending now in August of 2026. And here we bring together different technology providers, researchers, cities, and real pilot sites to test these digital twin-based approaches to indoor air quality. Next slide. So now I'll quickly give you a project overview with 4 basic steps so you know how we build our solutions. So the core goal of Twin Air is to improve indoor air quality and health through sensing, data analytics, and visualization, but always with a strong emphasis on clear and actionable decision making. And that's something we are discussing today. So it's not only about, as we know, it's not only about monitoring air quality, but helping users understand what it means and what they can do about it, how they can take an active role on that. Next slide. So the methodology for this, we combined environmental, medical, and technological perspectives to indoor air quality. So as you see here, we work across 5 high-level use cases. So we focus on transport, education, to workplaces and health, because we think indoor air quality challenges and decisions look very different depending on the context and the type of users. Next slide. And just here, I wanted to show you some images of our real use cases. So these are implemented through 10 pilot sites that include schools, hospitals, offices, residencies. And the pilots are critical because they help us keep the work grounded in real operational constraints and real users. So we always know where we have to focus. Next slide, please. So here our implementation focuses on developing this technological toolset that is linked with health and environmental studies, and it's designed around a user-centered approach. So this is where the digital twins come in, our work comes in. So it's not abstract models, but as a practical tool to support day-to-day and strategic decisions for the different types of users. Next slide. So here you can see a big image, a lot of information, but I assure you it's very easy to follow. So this diagram is a summary of the Twin Air concept. So here you can see that we integrate information from different types of sensors, wearables, regarding buildings, people, and also vehicles and other type of context. Then we are able to process this information with our analysis and tools and digital twins. And then we translate this into indoor quality assessment with recommendations and control actions to improve indoor air quality. So the key point here is the integration, because we know that data alone isn't enough unless it leads us to some meaningful insights and some actions that can actually help us proactively improve indoor air quality. Next slide. Okay, so I know there is a lot of text here, so I just want you to quickly look at the picture on the left-hand side. If you can see there, these are all of the digital twins we developed. So at the top, we focused on vehicle digital twin, human digital twin, building digital twin. Then within the tool sets, we worked on an indoor air quality rating tool, on an educational tool where users can actually interact. So it's like a gamification tool. And then we did analysis and applied machine learning calculations to building assets operation control and maintenance optimization tool where we can extract some recommendations. So this is the full tool set that we developed. And today I'm focusing on the ones in blue. This is the work that IAS worked on, integrating for the building digital twin. Each digital twin has their own dashboard, but now I'm going to share with you the things all of them have in common, so you don't are wondering how we did it, okay? So first, policy aligned and consistent by design. So the indoor air quality interpretation in Twin Air is grounded in shared contaminant libraries that are aligned with World Health Organization guidance and policy frameworks. So the results are consistent across assets and users. Second, the dashboards are, as I mentioned before, and that's the main message I want you to leave with, is that dashboards are a decision support tool. So we deliberately avoid like simple pass-fail views. So instead, indoor air quality is interpreted through thresholds, trends, and context. And this way we support informed judgment. Third, governance-aware user views. So we have different users, so they see the information at the right level that they need, but it's always based on the same analytical foundation. And finally, from data to accountable action, digital twins link the indoor air quality insights directly to recommended control and maintenance actions that will help users make the decisions that balance health, energy, and operational goals. Yeah, this is how we try to ensure that digital twins reduce complexity rather than adding opacity to the analysis. So if we can move on to the next slide. So here, just wanted to mention how IS supports the goals with our technology. So in Twin Air, IS is bringing together energy performance, indoor air quality monitoring, and actionable recommendations together in one dashboard. These actionable recommendations for Twin Air were carried out by University of Cambridge, which is also a partner in the project. So basically the focus is not just on simple alerts, but interpreting data through trends and context. So we have an evidence-based reasoning behind each action. And so this is essential, we believe, for trust, transparency, and long-term decision-making for users. So next slide. So we finally move on to a case study demonstration so you can see what we did with our dashboards. So in this case, I'm bringing you ETRA office in Spain, in Valencia. I don't know if any of you have been there, but it's a really beautiful city. So yeah, here we can see how the approach works in practice. So the goal here, as you remember from the beginning, is to enhance indoor air quality through monitoring and decision support. So the outcome was a set of interactive dashboards with clear KPIs and recommended actions that support both energy efficiency and occupant comfort. So this is a good example of how digital twins can move from just monitoring to practical user-centered decisions. So next slide, please. Okay, so here I won't go into much detail. I think the images are self-explanatory, but just to give you a bit of context, here we are using IS Live, which is a cloud-based platform developed by IS, and is used to give users access to all data-driven insights and to have a common point of access. So the first image the user will find is the building energy performance. So there they can see the energy breakdown of the energy consumption of the building. It's going to depend on the metrics and the metered information the building has. And then we can derive some KPIs. We can calculate the pollution and different metrics that the user may need. It's tailored to the needs of the user. Then next slide. Then we move on to indoor air quality tracking. So here we can see in the screenshots that we are able to get the floor plans with the sensor locations divided by floor, by room. We have different floors. And if you can see there, we are also able to indicate if the pollutant concentrations are within healthy thresholds or not. and that's why it's all red. I think we took these screenshots during summer, so it was very hot, and you know how it goes. And we also included some information for virtual sensors. So if you see at the bottom right, we have like some purple sensors there. They are replicating the behavior of the real hardware sensor. So in case any sensor comes into a failure or it's not measuring anymore, we are able to, sorry, I'm a bit sick. We are able to keep measuring with these predictions and forecast. Next slide, please. Okay, then once we have the sensors located in the room, the user can click and see, okay, the information for each one of the sensors. We are also able to see the graphs for the data for, in our case, we selected CO2, temperature, humidity, and particulate matter 2.5, but other pollutants are being measured. We are just including here the main ones that are related then to the recommendations. So it's valuable information and not just like a big list of a lot of pollutants and they don't know where to look at. Then next slide. We also included here some information on the air purifying systems that we implemented in these pilot sites and the filter metrics, so we can see the fan level and different filters that each filtration system has. One second. Sorry. Okay, almost there. So yeah, there we can access the metrics for the filtration systems that are also related to recommendations. Next slide, please. Okay. Yes, last but not least, here we have a section that is called actionable intelligence. That is where all of the machine learning based recommendations come into practice. Here we can see some information such as the current fan level. It will indicate us when we have to change the fan level to go back to reasonable concentrations, and these algorithms take into account not only the thresholds that we set, but also energy efficiency, also the maintenance of the different filters. So it is a complex algorithm, but it's all explained to users so they know how we get to these conclusions. And then the last slide. So the conclusions and takeaways. To conclude, I just want to leave you with this thought, and is that digital twins have a real potential to support better buildings and healthier indoor environments. So through data analytics, they enable data-driven insights that will help users to make informed retrofit and operational decisions aligned with the industry standards. Also in Twin Air and at the building digital twin level through platforms like IS Live, the emphasis is on responsible and user-centered design, keeping the humans in control. And yeah, finally, that the goal is to empower building users to make effective use of digital twins, even if they are not experts, by focusing on clarity, transparency, and decision support. So next slide, and thank you, everyone. And I look forward to the discussion. Thank you so much, and sorry for my throat.
We have to thank you utmost for that presentation while being unwell. You delivered it exceptionally well, despite being almost. So a big thank you from our side. Just to say, I think there's a lot of similarities there with what Sotirios was saying in his presentation. This focus on the users as well. I think the meaningful data and actionable data, that making sure that we're showing the data meaningful and in a way that's actionable. Gamification is very cool. We'd love to see. So maybe we'll reach out about that after the webinar, and maybe something similar from the last time as well, where one of the things that I had learned actually is that so I guess with the digital twins, you're able to see if there's a failure, which should mean that it's actually more cost effective, right? Because you are not having to take the sensor back to the lab to test if it's failed. You can already know, which already saves a lot of cost. So No, super interesting, and a big thank you again for that really great presentation. Now we head to multiple presentation with my friends and colleagues from the EDIAQI project, Michela, Pier Giorgia, and Sumit, who will be presenting today the work that we're doing in the EDIAQI project. So please take it away, Michela, Pier Giorgia, and Sumit. The floor is yours.
So, hello everyone. Thank you for having me. I'd like to start with a simple question. Why do some digital tools just work for us and other feel like frustrating and makes us want to give up? To answer this, we need to set a common ground of what we mean by user experience or UX. I manage the UX design team in DataNext, and I can tell you that user experience is about how people understand, use, and trust the system in real life. This is the UX Honeycomb by Peter Marville, which is a framework that describes the key qualities of user experience. And a good system, a good product or service should be usable and useful. So users must be able to reach their goal easily, and the service must solve a real problem for them. It also needs to be accessible, desirable, and credible, so users feel included and engaged and confident. And people need to be able to easily discover its functions so they can use the system without thinking too much. Next slide, please. But how do we design for a good and meaningful experience? We start by asking the right questions. Through user research, we understand who users and stakeholders are, what they need, what problems they face in real contexts. From there, we define the problem and we focus on user needs rather than technical solutions. We then move to ideation, where we explore different solutions and then we make them tangible through prototypes, which are simple artifacts that help us visualize and discuss ideas. This is where co-design plays a key role because users can be actively involved in shaping the solutions. And finally, we test the prototypes. We learn what works, what doesn't, and we use those insights to refine the solution and repeat the cycles. Next slide, please. So in EDIAQI, we followed this approach involving users at different moments of the design process. In the picture, you can see Valentina, our colleague who carried out all the work and the facilitation of the workshops. We started with user research, where we interviewed key stakeholders to understand their needs, their context of use, and decision-making situation related to indoor air quality. Based on this work, we defined 5 user personas with different goals, which led us to a key insight: the need to support 2 opposite levels of expertise for generic users and expert users, such as decision makers. We designed some concepts, also using competitive analysis. We participated in a UX challenge at the University of Trento, where a group of solvers created 3 different concepts that we used as an input for the workshops where we discussed them. We built then on the insight of the first analysis workshop and ran a co-creation workshop using specific exercises and sketches to refine ideas. And the outcomes informed the final dashboard, which Pier Giorgio will show you in a moment. Next slide, please. I'd like here to briefly share some key insights from the workshops. What you see are some sketches produced by participants. They represent early ideas, but also very clear design direction. A strong theme was the need for immediate understanding with clear color-coded indicators that make air quality readable at a glance. Another important insight was the focus on health impact and actions. So users asked for short explanations combined with concrete and timely suggestions they could act on immediately. They also needed for different levels of informational details and expressed the importance of engagement and looking at data over time to understand trends, recurring situations, and encourage positive behaviors. Next slide, please. A quick peek inside the simple version of the dashboard, designed in this case for school environment to support awareness and everyday decision making. At the top, users can see, I hear a microphone maybe. User can see synthetic air quality indicators for multiple classrooms, which supports social comparison with other students. The dashboard is aimed at non-expert students here, such as users, such as students, parents, or teachers, because it offers an immediate overview based on qualitative indicators from the last 24 hours. And also it provides an immediate action cue, such as open the window. Users can, though, switch at any time to the advanced view through the toggle at the top, which we can see in the next slide. So this is the dashboard for advanced users such as school manager, facility managers, and decision makers. This version also supports deeper analysis and informed decision making. Users can explore air quality data across different time spans, not only 24 hours. And the dashboard offers a more detailed and flexible exploration of parameters, adapting to users' technical expertise, responsibilities, and objectives. And at this point, I'll leave the stage to Pier Giorgio, who will walk you through the advanced dashboard in detail. Thank you.
Thanks, Michela. So we can go to the next slide, Alex. So indeed, the Ferrara dashboard prototype was not part of the original project scope. Neither the UX design work was planned as a format deliverables. But during the project, it emerged in an organic way from the pilot experience itself, thanks to the interaction with buildings occupants. So with them, with schools, with people from public offices, we understood that the idea of visualizing air quality data, making their interest clear enough, at the end bring up us to the need for developing a dashboard as a sort of a natural response. What began as an unplanned initiative at the end played the sort of role of proof of concept, shaped directly by the needs and expectations of the people that the project itself was designed to serve. So now we can see a short video of the prototype in the next slide, and I leave the floor to the video and the audio. Okay, thanks, Alex. So the user interface prototype has been developed using Streamlit, that is an open source Python framework to deliver interactive data apps. But let's focus a little bit on what's behind the user interface. So the overall architecture is deeply focused on the OGC SensorThings API standard that has been adopted in the EDIAQI project to get interoperable data sharing among all pilots of the project. SensorThings is an open standard providing a geospatial enabled and unified way to interconnect the Internet of Things, the IoT devices, data and applications over the web. That practically means that different software clients developed in different languages and built on different technologies may be enabled to interact with the standard APIs in a standard way to browse, search, view, download time series like air quality data, like in our case. But the standard itself is already applied in many countries also for other themes, from traffic to water to soil. Next slide, please. Okay, among the potential offerings emerging from this work is the development of interoperable indoor air quality dashboards that have to be accessible to non-specialist users. Moving forward, this means evolving what began as a quick and dirty proof of concept into a scalable, secure, and robust system. A transition that demands rigorous and repeated testing at every stage. This path runs through a well-defined minimum viable product, built lean but built right, followed by deliberate re-architecture and refactoring to ensure the platform can support long-term growth. Of course, this also means to further refine and reshape the implementation, considering the indoor air quality market. Now, to speak about possible business cases we studied, I leave the floor to Sumit. Please.
Thank you, Pietro. Yeah. So I'm going to try to sum up the things that we have been working on in the second half of the last year. So as my colleagues mentioned, that there was a collaboration with the University of Trento and DataNext, and there we tried to create like a business study where we conducted research, mostly desk research, to understand the key activities, what could be the sustainability program for if the business were to come out of it. But then we also thought that maybe we can take those findings and try to extrapolate them to create like a digital ecosystem around the dashboard. And that's why we're trying to understand what are the different stakeholders that we had identified, what do they actually need, what do they actually struggle with. And in this case, we tried to focus mainly on the primary stakeholders, which are like municipalities, schools, NGOs, because they need not just a dashboard, but maybe insights, as my colleagues have mentioned already. So now the question kind of becomes, how do we translate this raw data that the dashboard is showing into something which can help them make effective decisions and communicate properly? Can we go to the next slide? Okay. So as my colleague showed the dashboard video that we just saw, the research revealed that there is actually some gap in how the data is showed and how usually users interpret it. And it also kind of make sure that how well they are retained using the product. So the gap here is that the school admins and the facility managers, whether it's a school or public admin buildings or office spaces, they usually don't have the time to analyze graphs. So they need answers to questions, for example, like which rooms need my immediate attention, or how do I prove that my building or our building is compliant with the regulations. And this is also backed, and this is also backed by another desk research that we had found, if you click next again. So there was a research that was done in Boston where they did a lot of, conducted a research around the schools in the city of the Boston. And they realized that the staff actually felt more powerful and encouraged to use their product if they were actually helping them with automated reports and decision support. And there is also backed by the startups that are coming up like Airthings. For example, in Norway, one of their USP is actually selling the customers compliance reports as well. Can we move to the next slide? So the solution here comes is that maybe we can have an intelligence layer built on top of the dashboard layer. It does not replace the dashboard, but it translates the sensor data that we have been getting into different types of outputs. For example, some of the things that came out of the test research were like health reports, which highlight problematic rooms and patterns, maybe like prioritized actions for the staff, maybe some sort of like automatic ticketing system so that they can know who should work on what at what time, compliance documentation for audits, funding, and the last is like maybe summaries that I mean, for example, the principals of the school, they can share with the parents or city councils. So these are just some ideas that came out of the research we had conducted earlier. So this turns the dashboard from just a monitoring tool into an intelligent system with recommended actions. Can we move to the next slide? So over the next few months, the plan is to focus on the UX and the service design of this digital ecosystem that we are talking about, this intelligence layer. The plan is spread across several months, where one month first will be just about problem discovery and definition with potential end users. This will be supplemented where we try to use journey mapping to understand the user needs. In the second month, we will try to create some sort of prototypes using co-design and other design methodologies. The goal here will be to work with the active stakeholders, either synchronously or asynchronously, to create and refine the design concepts. And then the third will be the testing and the delivery. In this phase, we will plan to do some sort of usability testing on the intelligence layer that we will come up with the active stakeholders, and we will try to iterate and maybe have as an MVP as a part of the end goal of this plan. And along with that, the plan is to have a validated design with the users, or at least some sort of like design guidelines, which could be ready to integrate with the dashboard. And that's it from my side.
Thank you very much, Sumit, Piergiorgia, and Michaela for that very interesting look at the work that we're doing at EDIAQI. I think the mantra of today's presentations was the users. As we saw in all of the presentations, the users were, I think, a key focus here. Very interesting to see the honeycomb concept methodology to understand kind of UX needs. The iterative design, I like that you're not just thinking about the users at the end, but you're thinking about them throughout the whole process as well, right? And then very cool to see that it was a natural response. It's one thing I didn't realize, that the dashboard became a natural response and not something that was actually planned within the project as well. And very cool, obviously, to see, and for me especially as somebody involved intimately with the EDIAQI project, how we're going to take these innovations, these things that we've created, and really leverage them beyond the project, right? So that they are not something that gets pigeonholed away, but something that becomes, and there is a market out there. We've seen that in some of our other webinars. There's a real market out there now for indoor air quality, and more importantly, a moral imperative for that. So please, speakers, do turn on your cameras. We are now heading to the panel discussion portion. We will start in a classroom style with Sotiris, and we'll go from in the same order. I'm not so creative. So Sotiris, please do. I'm not sure if you have your camera on today because I've been having a bit of difficulties with the cameras.
Yeah, can you see me?
I cannot, but I'm
Yes.
not sure if others,
Okay.
Yes.
can.
Yeah.
So Sotiris, when dashboards simplify IAQ data into color-coded thresholds or composite scores, what risks do you see in terms of misinterpretation or false reassurance?
We have to understand that there is a complex task for those that they develop an indoor air quality index or outdoor air quality index. They have to determine the right breakpoints for upper and lower limits inside the different levels. And that eventually is what is going to protect the population or the users of the specific dashboard or index. So once we have established that very precisely, I think we don't leave any room from misinterpretation by the users. Specifically with GoAQS, we have very strict limits either way when we are saying that the air quality is good. And once we move in the moderate breakpoint, again, the limits are very meticulously investigated and put in place in order again to protect people that potentially they will be in that specific breakpoint at some point of the day. And then we have the unhealthy, which is the red one, the pronounced red, that it's gonna communicate very clearly to the users that they have to leave the room, basically, or take measures, very important measures in order to fix the air quality inside the building. So yeah, and in comparison with other indexes out there or scores, I think GoAQS tried to do that, to be protective, even if we are in a level of not very good air quality. Because in some cases, people maybe are not on top of what's happening with the air quality. So we will have to be in that position in order to protect them in advance, right? And an index is working as a proactive measure, right? It's going to tell you that something's happening right now. It's not going to inform you about something that happened, 2 hours or an hour ago. Thank you.
Thank you, Sotiris. There, I think also building on what you said before, vulnerable populations, right, as well, by taking these very meticulous standards, you're also ensuring for the most vulnerable populations, right, poor indoor air quality there as well. And maybe just a big shout out again, very important initiative, GoAQS. We all deserve to breathe the same healthy indoor air, and we need to define that. And at the moment, we only have the WHO guidelines for that. So anyhow, to underscore it a little bit more. Okay, Marina, please, can digital twins help reduce complexity for users, or do they risk adding another opaque layer?
Okay, thank you for the question. Well, I think in overall, the idea for digital twins is to reduce complexity, but obviously it depends if they are designed or done with transparency and also as a decision support tool and not just like a black box where you don't know what is happening. So I think the risk can happen, as you are mentioning, of adding like this opaque layer when you show maybe like big loads of data or model outputs without context and clarity, and the user doesn't understand what's going on. So in the case, for example, of TwinAir, we address this by implementing indoor air quality recommendations, metrics through policy-aligned thresholds. We do data processing and clear ratings that are indicated to the users, and then machine learning-based analysis and predictions, like rather than just raw signals alone and no explanation whatsoever. So it's also important that the digital twins are, as they mentioned before in the previous presentations, it was really useful, is that they are tailored for the audience and for the users. So it can be depending on the different type of assets. Like in our case, we have buses, buildings, and humans, and then the audience. So I think as long as these things are taken into account and everyone is getting the needed information to support their decisions, the right level of detail, then digital twins shouldn't add complexity, but translate information in a way, in a human-centered way that users can really understand. That's what I think. At least that's a very big focus that we also have in IES with IES Live, which is the as you saw, like the main dashboard that we have. We are always working together with the UX team and with feedback from users on how we can make this clearer and better for the user.
I think today the mantra is definitely the user and working intimately with them. I think it is very true as well that that's where you can get a lot of fruit in terms of understanding the right approaches. So I like this focus there on the users. Now, building on what Marina has said, Michaela, what design principles help transform raw IAQ data, which you've already touched upon, but maybe you can extrapolate a little bit more into something actionable rather than intimidating?
Well, there are several design principles we can apply to focus on awareness and concrete actions without creating fear. I'm naming just a few of them. One is progressive disclosure, which happens when we disclose information through progressive levels of detail. This makes it possible to manage the user's cognitive load and to give people just the amount of information that they need. So a basic view, for instance, for students, focuses on immediacy, while an advanced view for decision makers offers analytical depth. This prevents non-expert users from feeling intimidated by complex charts, while providing data depth for those who need them. Another one is data synthesis, which means that instead of using single row values that can feel complex to understand for non-specialists, we use simplified numerical indexes to provide a single unambiguous piece of information, which is also actionable. Okay, so the users perceive their air quality as a comprehensive value, and this reduces anxiety. Another one is visual familiarity. So to make the invisible visible, it requires the use of universal languages, such as traffic light color coding or emotional indicators, such as smiley faces, for instance. These elements act as behavioral triggers. So the color and the shape communicate urgency and reassurance. And these can be associated with interactive maps, which can also help to make the risk less abstract and more physical. And finally, action orientation through baby steps, for instance. So the fact is that if you know you can do something about a problem, you fear it less. So a key principle in our design was the nudge to concrete and timely action. So associating measurements with practical and contextual advice, such as open the window, transforms these abstract concepts into a proactive management setting. And this, in this way, the design does not focus only on displaying a problem, but it provides suggestions, concrete actions, behaviors that people can act on to improve their well-being.
Michaela, I must say, I feel like I've learned so much about UX now, and a very cool concept that I might use aside from UX discussions, actually, to be honest with you. And I really must say, it makes a lot of sense to be this sort of baby steps approach, right? And this sort of progressive disclosure, which kind of maybe builds trust as well. And there's a little bit about like the interoperability, right, as well, making sure that you have specific kinds of language, right, so that this knowledge is sort of transferable in all the ways. So very interesting. Okay, building on that now, Pier Giorgio. The Ferrara dashboard began as a project output, right? But what does it take to transform now this tool into a scalable, sustainable digital asset?
Thanks, Alex. So that means moving from a prototype into a real digital asset. So turning a dashboard like the one that we prototyped for Ferrara into a real scalable digital asset, in my opinion, requires a paradigm shift. So we need to shift from a deliverable mindset into a platform mindset. That means that from a technical point of view, This means a modular architecture that is already what we consider also from the prototype, with a clear separation between the different layers of the architecture. So the data ingestion, the analytics, and the presentation, enabling each layer to evolve independently from the others, and in particular avoiding vector lock-in. And this can only be possible through the adoption of open standards like the one that I mentioned before, so the OGC SensorThings API standard. This is a very, very crucial point, because for the time being, the IoT world is characterized by non-interoperable, closed, proprietary products. That is exactly what we call a vendor lock-in effect. Second, equally important is the governance. A platform needs a defined ownership, a funding model, and a sort of home within an existing operational function, rather than living as a sort of orphaned project output. That means that scalability has to be considered, and usually scalability is always fails without someone that is accountable for maintaining and evolving the tool. And finally, but it is a very important consideration, user adoption must be designed from the very beginning. So independently from having a prototype, user adoption of an operational platform has to be considered from the very beginning and built upon and around real workflows, and not just considering data availability.
I think interoperability is another one of the key words from today as well. And looking at the governance model there, I think that's it. I think it's one of the strong points as well now about the EDIAQI project, that all of the assets and the innovations that we're creating form part of these sort of modular building blocks, right? And if you have a particular IAQ challenge, you can kind of put these building blocks together and then have a specific customizable solution as well. Now, so anyhow, I'm also touting what we're working on, but I'm very proud to be working on it. Let's move now back to Sotiris again to build on top of that. In an operational building context, which signals actually trigger action? Is it the trends? Is it the exceedances? Is it the comparisons or predictive alerts?
They're actually all of them, right? And I divide them in two categories. We have the immediate signal actions, like a score when we receive an alert or the user is looking at the dashboard or the display of the device that gives information about the current situation of air quality and potentially a problem. And then we have the long-term analysis through the trends or the limits that we have established inside the specific dashboard, and the reports we generate manually or even with the use of AI technology in order to help us identify any pattern that may be present in a specific location. Personally, I had an experience with that. And I did a study in an office some years ago, and for some reason at 12 p.m. Every Wednesday, the particulate matters sensor was always going off, like for some reason. And I didn't understand why. First I thought that maybe the cleaning person is there and is doing some kind of a task that is influencing dramatically the sensor. But eventually, after speaking with the people inside the building, it turns out that they had programmed a device that missed water into the environment, and they used tap water, which means that they are also including all the minerals that they can be found inside mineral tap water. So all of those basically particles, they were present now in the environment. So that was the reason the PMs were high in that specific location, that specific time. And I was able to find out about that, first of all, because I was able to analyze the long-term data, right? And see the pattern occurring every time, every Wednesday at 12 p.m. And then I had to go further and speaking with the people inside the building in order for me to understand the reason and potentially telling them that if you want to continue using this product, use it with distilled water that doesn't have any minerals inside.
So I think, thank you very much for the very good practical example as well, right? That a very important part of this is also understanding how to specifically use the actual sensors, right? And I think a part of that is the capacity development as well. I know we did some work on the training. I forgot exactly what, and actually Pierre Giorgio on our side was behind that, doing these sort of training sessions, which are, sorry, doing a bit of promotion here. I have an opportunity. Please do check out our YouTube channel. We have some very interesting trainings there that might interest you very much on this kind of specific topic. Okay, heading back to Marina now. I'm building on top of that, and obviously the focus on digital twins. What role can digital twins play in supporting renovation and long-term investment decisions under the European Performance of Buildings Directive frameworks? Please take it away.
Okay, thank you. Thank you for the question. I think it's a really good question, considering that I work for a company that develops digital twins to meet these retrofit targets and everything. So basically, what role digital twins play? I would say a key role. So we all have a bit of context. So under EPBD, the challenge is actually not just setting the targets, but it's making like credible long-term renovation decisions that stakeholders can trust to meet these targets. So how do digital twins help with this? Well, I am trying to gather my thoughts, and I think they help in 3 key ways. So the first one is we are able to create a robust performance baseline where we combine measured data and simulation. And then in this way, we increase the confidence in understanding how the building actually behaves for the stakeholder. Once we have this baseline, the next step would be that we, with the digital twins, we are able to test retrofit and renovation scenarios before any capital is committed. So we can analyze energy, carbon, and comfort impacts compared in transparent ways. So this directly will support the investment-ready decisions rather than just having some theoretical plans that are not supported by any physics-based analysis, for example. And so third, they help closing the loop because we can track performance over time and verify the savings and the outcomes that are actually being delivered, which is, we believe, is essential for EPBD-aligned pathways and long-term compliance. So in that sense, I would say that digital twins turn EPBD from a policy ambition into something that is actually operational, monitorable, and accountable over time. So.
Thank you. We might have to reach out to you here on the policy alignment, especially with the roadmap coming out. Very cool work that you guys are doing there. And I think obviously the EPBD, the European Performance of Buildings, like is a real unique opportunity for us, right? I think usually people say, you know, more regulation, well, there's a strand of that, right? More regulation means that there's less business opportunities, but sometimes no, there's more business opportunities, right? That this is a clear business opportunity for a healthier, cleaner indoor environment. So, okay, I will stop with my pitching there. I will head now to Sumit here. Sumit, how can, I'm building on top of that, how can dashboards communicate health relevance rather than just environmental metrics?
That's a good question, because there comes the part of the behavioral sciences. So in my opinion, dashboards are actually like a very good way to communicate complex data. But to communicate health relevance, dashboard needs to be more than just saying, okay, this is the current CO2 level. And maybe start answering questions like, what does this mean for people in the room that where the carbon dioxide levels are actually rising? And then if it is rising, what should we do? So that's exactly like for the next few months, that's exactly the shift that we are trying to design at Data Next and with EDIAQI. So I think to achieve this shift, there are actually 3 things, I think. Translating the metrics that the dashboard shows into something which humans understand as effects. So as humans, we are kind of very bad with numbers. So just saying that the CO2 level is this, it does not really help us understand what it could mean as an impact on our health. So shifting the language from just numbers to something like, okay, now the carbon dioxide is high. So if you are in the context of the school classroom, then that could mean that there is a reduced concentration among students. Or if there are some students with respiratory diseases, for example, with asthma, they can also suffer more with the higher carbon dioxide levels. And then second is like also tailoring these messages that comes with different effects to specific roles. For example, the message for a teacher inside a classroom would be so different for someone who's working as a facility management staff. So we also need to understand like what are the priorities for the different roles that we have identified, and also talking about the decision and the report supporting layer. Um, the language simplification also plays quite a bit of a role here. So there was a study I remember that was done with the kids from I think 8 years to 13 years of age. For them, it's quite difficult to understand the jargon that comes with indoor air quality. So they used like metaphors like the example of a living cat to help them understand what it is when the indoor air quality becomes bad compared to the external air. So this kind of communication and the shift that needs to happen in the behavior of the people, it does not happen over time, but with like continuous, correct, real-time reporting, users start to believe in the systems. So I think like here the goal is to actually provide a story of the health risk that comes when the indoor air quality gets so bad, and what is the current progress and what are the next steps that you can take, instead of just saying this is the environmental data. Yeah.
I think the tailored point as well is very critical there, right? Building on this kind of users focus. And yeah, very interesting to think about as well. Now with the carbon dioxide levels, I remember from one of the last talks that we had as well, is you can also tell, for example, pathogens, right? That if you have more CO2, there's a more likelihood of catching, you know, a cold or something that maybe your classmate or your colleague has as well, right? So even more on top of that as well. Okay, closing off our panel discussion today will be Pier Giorgio. Do a little bit swifter so we can head to some of the questions that we have today. We have quite a lot of questions in the chat. So Pier Giorgio, closing today then, from a strategic perspective, how much complexity can a scalable IAQ indoor air quality platform realistically carry before it becomes unmanageable?
Very, very complex question. Well, complexity, in my opinion, becomes unmanageable when it exceeds the organization capacity to interpret, act on, and maintain what the system produces. So the limit is at the same time organizational and technical. And probably the safest approach is a sort of a layered complexity. For instance, a reliable core of high-value indicators like CO2, PM2.5, temperature and humidity as the foundation, with advanced analytics to be made available to those with the capability to use them, not for everyone by default. And 3 possible warnings that a platform should consider. The first one is the integration overhead that starts consuming when more resources. So that starts consuming more resources when the insights justified. The second one is conflicting stakeholder needs that make it impossible to maintain a coherent product direction. And the third one is per site customization that erodes the economies of scale, the platform. And this drive us to define a clear scope boundary So that means what the platform owns versus what it hands off, and what this is, in my opinion, what keeps the complexity manageable over the time.
There's the layered approach, I think, is the key word as well, right? The sort of progressive disclosure. Maybe I'm not connecting it right, so do correct me if I'm wrong there. But I do think it's very interesting to kind of sort of build up and to ratchet up, if you will, sort of like an escalation process. So we went from inclusion, the users was the mantra throughout. Then we took a look at translating this important moral imperative to make sure that this data is actionable to also the economic opportunities there as well. I saw Salius, he raised his hand. He was one of our speakers at the last webinar. I'm going to give him a chance today if he wants to ask a question, if he can be as super swift as possible, please, with the question. Do write in the chat if you want me to give you the microphone. Or you can turn on your microphone as well and just speak.
Hello.
Go ahead.
Can you hear me, guys?
We can hear you. Please go ahead, Salius.
Oh, thank you for this wonderful webinar. Really enjoying every minute of that. I wanted to ask a question. I'm so glad I'm in the indoor air quality entrepreneurial startup for endeavor, let's say. And it's a bumpy road because I had to learn that the data layer is something that no one really knows, general population, and they are not concerned. They don't want to know about that. But then, and you actually cannot tell anything about on the data level. So now we're entering a intelligence level layer, which is absolutely amazing. And I think that is what is going to make a change here. But my question is, between data layer and intelligence layer, in order to make actually implementable things that we're talking about, adaptability aspect here, or integration aspect, we have to face the obstacle of convincing population, society, businesses, municipalities, schools, hospitals to actually heavily invest in IoT infrastructure. On a data level, there was not sufficient arguments for them to do that. Now, when we're entering intelligence level, maybe we will be able to actually convince them that with this investment, you will access this intelligence level. But where I see that the mismatch is that on a business side and actual practical application of what we're working on here is actually the investment gap. And do you have an idea how we are going to bridge this, how we're going to convince population that in order to implement this, we will have to massively invest in IoT infrastructure, specific infrastructure? Thank you.
Thank you, Salius. I think it's to you, Pier Giorgio, because you were the last speaker when he raised his hands, but we give the floor to all, and maybe to be a little bit swift so we can get to some of the other questions as well. Pier Giorgio, you're first.
Thanks. So if I properly understood the question, and also considering the question that Saulus put in the chat, I would say that at least in the recent years, public administrations at the different levels, national and subnational levels, are already investing a lot of money. But just few of them are focused on interoperability. And probably the reason is, again, the lack of knowledge about already existing open standards, like the one that we adopted in EDIAQI, that is a standard freely available, implemented by open source solutions and maintained as a standard and also as implementation, robust enough and flexible enough. Just to give you some ideas, the air quality, the outdoor environmental and outdoor air quality observations collected by the European Environmental Agency are provided through a publicly available sensor things endpoint, so through standard APIs managed, maintained by the Fraunhofer Institute. And that means that the observations collected from, I think, January 2018, so almost 8 years ago, up to near now, are available for all stations, all monitoring stations spread all over Europe, more than 5,700, with billion. I think that now the number of observation is more than 1 billion of observations. The problem is that almost nobody or just few people are aware about that. So it is, my opinion, mainly a matter of raising awareness among public administration to address in a more clear and better way their own fundings, because they are already spending a lot of money in not only in infrastructure for IoT devices, but also for collecting, sharing data, but almost ignoring the availability of standards like this one.
I'd let Sotiris maybe come in, and then if you have very quickly, because we have some other questions. Sotiris, please.
Thank you. What I want to say is that, yes, we need lots of IoT devices. And the problem that I see is happening not only in Europe, but in the global scale, is that governments, they do invest, but with an expiration date, which means that after 3-5 years, they don't support them anymore. So everything that they have built collapses immediately. And then currently with the AI revolution and so on, we are shifting our attention away from IoT. And we believe that AI is going to solve the problems of air quality, but AI needs the IoT in order to gather all of this kind of information, analyze it in a constant way. Remember, air quality is something that changes constantly. It is not something that we will take a measurement today and it's going to be fixed for the rest of the year or decade. So we have to be on top of our game all of the time, and we need technology and IoT devices for that.
Salius, very quick, if you have a perfect then. Okay, we're going to move on to Marina here. Marina, there's a question from Bimarsa. So can the digital twin also do source apportionment modeling for PM 2.5 based on the environment? And if not, how do you determine the source of the pollutants?
Okay, thank you, Bimarsha, for the question. So actually, how we do in TwinAir is that we have 2 work packages that are focused on indoor air quality assessment and health impact assessment. And through the pre-intervention and post-intervention sampling phases, we carry out these activities, data measurement, pollutant tracking, and that way, these measurements allow us to, we also do user interviews. So they allow us to do indoor and outdoor air quality relationships modeling. And we also do analysis on how do I say in English? Epidemiological and statistical analysis for the health impact. So actually, these are separate work packages in the health aspect. And so, but the digital twins do not carry out these analysis. That's how we do in TwinAir. Maybe in other contexts is different, but yeah.
Maybe just to build on that, to say there won't be zero pollution by 2050 unless we tackle indoor pollution sources as well. So understanding where they come from, super critical, and very interesting to see that work that you're doing. Sumit, Nair, you were very popular. You have 2 questions for you today. I'm going to try to wrap them up in one. We kind of answered and addressed Salius's question. So for your future plan, are you open to work with a white label IAQ platform that has most and then I think he continued it, most of your items already built in. We have this available under indoor care. So what do you think about that? About having it already built in? Maybe there's the issues of the vendor lock-in and stuff. I'm already saying, I don't know. Samit, take it away. The floor is yours.
Okay, just I think during the presentation, what we had presented, it just came out of the desk research, and this is where when I was talking about like role-specific needs that we still need to understand, because here there's kind of like a verification step that still needs to happen, because what we found out through the desk research, yes, it creates some sort of urgency, but is it actually what the roles that we are dealing with, the users that we are dealing with, is it actually what they need here as well? But if the research with them shows that, okay, this is what the ideas and this is what the needs are, and this is what the kind of system that they would need in the future, and if it can help us, to create some sort of like an MVP very quickly and test it quickly, it could be nice to have a collaboration in the future. Yeah, but it also depends, like the things that they're the users want, and this solution indoor care. I'll have to check what they do, if they align as well. So.
Michaela, if you want to build a tiny bit as well, just as the only person not to speak in this section on the UX, I think it'd be nice to end there a little bit, going back to the user and the user needs, and we'll do some closing. We'll end a little bit late, 1 minute or 2 minutes. Please, Michaela.
Yeah, given the questions, I would like to go into add a bit to Pier Giorgio's answer about how can we convince administrations to invest into infrastructure. And as people, we always make our decisions based on continuous evaluation of cost versus gain. So Pier Giorgio already mentioned the cost part of the problem. So whenever we need to convince people to do something or to pay attention to us, we need to work on those 2 dimensions. So lowering the cost of adopting something, of doing something, and increasing the value of doing that. I know that this is very psychological, very theoretical maybe, but I think this is how our minds work,
I think psychology is everything, and I think understanding that and then using that for behavioral change, especially for things that are morally imperative, like in this case, it's both environment and health-wise. And it's amazing to see basically how all of these different strands, you're talking engineering and psychology, are all kind of coming into one. An issue that is very relevant, right? 90% of our time indoors is the statistic. It might not be the case everybody, but it's definitely the majority of the time that we spend indoors. So thank you to my amazing audience. Please, I hope you have your telephones out, because there's tons of QR codes that are going to be thrown at you right now. We encourage you to become part of our vibrant community by joining the Twin Air project, co-members with us of the Ideal Cluster. This is their LinkedIn channel. I'm going to hold it there for a second. For seamless updates, information, please scan these QR codes below. Now, next we have Data Next here. So I'll wait here 5 seconds. Okay, I hope you have your phones out and you're ready. Next is the Ideal Cluster. So you've got lots of channels you can follow. Today you'll probably end up following another 10 different channels. And finally, us, but last not but least, the EDIAQI project. You have LinkedIn, Facebook, Mastodon, YouTube, Instagram, X, you name it, we have it. Please join, please do follow us. And finally, we extend our heartfelt gratitude to our panelists for their invaluable perspectives. and to you, our audience, for the engaging discussion that brought this event to life. With that, we conclude today's session. Until next time, stay connected and informed. And of course, wishing you all excellent air quality, both outdoors and indoors. Thank you and goodbye, everyone. Thank you so much.